Hello everybody, welcome back to Planet X News. It is September 21st, 2017. And ladies and gentlemen, I ran across a pretty interesting article over here on spaceweather.com. And I stopped over here like I do every day, and I was about to review some information on a very, very active sunspot that's going to be turning towards Earth in just a few days. We'll get into that later on this afternoon. That is sunspot number 2681. And then I ran into this information here, and the headline reads, Spacecraft Buzzes Earth en route to asteroid. And then I noticed the name Bennu. I remember reading some information about this hazardous asteroid about a year ago. And then I see the rocket, OSIRIS, the spacecraft. I start reading the article and the information, and it was very interesting. So once again, the article headline, Spacecraft Buzzes Earth en route to asteroid. NASA's OSIRIS-REx spacecraft is going to fly past the Earth tomorrow, September 22nd, slingshotting itself toward a potentially hazardous asteroid named Bennu. At closest approach, OSIRIS-REx will be only 10,711 miles above the Earth's surface, well inside of the Earth's geosynchronous satellite orbit area. Now the map below shows the circumstances of this encounter. And what they're talking about the actual spacecraft, not the asteroid itself. Now moving further down in this article, because it begins to get very interesting. It says, during the brief hours before and after closest approach, the spacecraft could shine with as much reflected sunlight as a 9th or 11th magnitude star, well within reach of backyard telescopes under the ground track. Observing tips are available, naturally, from NASA. It also states that NASA is visiting Bennu, this massive asteroid, before it visits us. Now, Bennu crosses Earth's orbit every 6 years. In the year 2135, the asteroid may enter a small keyhole between the Earth and the Moon, where the gravitational pull of our own planet can tweak Bennu's orbit, potentially putting it on a course for Earth later that century. Now, currently, the odds of a collision 150 plus years from now are no more than about 1 in 2,700. Small, as they say, but enough to prompt an $800 million space mission. And here's a little example of the size of this creature that they call Bennu. 510 meters in diameter, comparing it to the Empire State Building of 443 meters high, and the Eiffel Tower, 324 meters high. And then moving further on down in the article, it says, arriving in late 2018, OSIRIS-REx will spend more than a year flying in close proximity of Bennu, using 5 instruments to survey the asteroid. Very, very interesting, folks. You know, and as I was going over some more of the information, excuse me, I'm just going to pan down here real quick, and I was looking at some of the recent and upcoming near-Earth objects. And what do I find popping up? 0.8 lunar distances. Near-Earth object 2017, SM number 2. A lunar distance, ladies and gentlemen, is equivalent to approximately 238,000 miles. So this will actually be a very close call. The the next near-Earth object, which is today, actually. Or actually, these were yesterday. I'm sorry. This was object number 2017 SR2. It came within 0.2 lunar distances. So these two objects flew by yesterday. Didn't even know about it. But then we move down here to October 12th, as you see highlighted in the darker color. 0.1 lunar distances. We've talked about this object before, 2012 TC4. So I'll gather some more information on this, and let's see how many visual looks that they've had at TC4. But 0.1 lunar distances is very, very close, ladies and gentlemen. Very close. And that will be occurring on October 12th. I found the article and the information related to Bennu pretty interesting. Pretty interesting how they're saying that you'll be able to see this spacecraft shining in the sky. Very interesting. So whenever you go over here and you click on the photograph, it takes you straight to the OSIRIS official website. Gives you a bunch of information, the same as what you are viewing on spaceweather.com. Gives you a little bit more information. Look at the average speed, 63,000 miles per hour. Equatorial diameter, 500 meters. That's a pretty big object, ladies and gentlemen. Orbital period, 1.2 years. Earth approach, Bennu comes close to the Earth every 6 years. Now, again, I do remember reading about Bennu last year, and the information was, kind of sparse, but it seems now they're coming out with more and more information pertaining to this massive, very massive space object. So if they're keeping their eyes on it, and they're spending $800 million to fly out and meet up with this asteroid, it's definitely an emergency situation. Now, their timeline, well, look, folks, we never know. We never know when they're telling us, oh, maybe this will crash into the Earth in the year 2135. Okay, well, I'll be dead and gone, and so will all of you. But it does make me wonder when they put this type of information out, and they make such a big deal of it. And then they're telling everyone that you'll be able to see the spacecraft shining in the sky. It will be bright. It's definitely worth looking for. If you have a telescope, you can go to the OSIRIS website or search it through NASA and find out exactly the timing. If you want to bust out your telescope or maybe a set of binoculars, you never know. You may actually see more than the OSIRIS spacecraft. And then, ladies and gentlemen, they followed all of this information up with a pretty spectacular video, and I have it for you right here.
The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own, until now. Today, NASA is sending a spacecraft called OSIRIS-REx to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.